Hey guys, Mr. Smith here, coming at you with a little Plinko analysis action. So hopefully you've done your practice with Pascal's method, maybe did the warm up, hopefully watched a bit of Plinko gameplay so you know what's up with Plinko. I'm going to help you guys completely analyze what happens when you drop a Plinko chip in slot A. And then you guys are going to do slots B, C, and D as part of this assignment and do a few more things as well. Now, I want to mention something off the top. When you drop a Plinko chip in any slot, let's say slot A goes between these two pegs, it comes above this peg. It can either go left or right, and it's 50-50. It can't jump over like two spots. So if you drop in slot A, it's actually physically impossible to get to any of these slots that I'm kind of shading in here. So I'm going to do that on mine just to visually kind of create that boundary. It's like, okay, I know my chip can't go past here. And you can actually see that it's impossible for a Plinko chip to drop from slot A and reach this $100 slot. Physically impossible. So now that we've done that, we're dropping in slot A, and we're just going to apply Pascal's method. So 1 and 1, and carry the ones to the side. 1 plus 1 is 2, 1. And maybe if you're like me, I like to just kind of get that outline done, and I'm going to drop my ones all the way down. Some people just like to go row by row, and that's fine. The next row, 1 plus 2 is 3. 2 plus 1 is 3. There's no slot over here for a Plinko chip, so that's it. Now, this is the first line where this doesn't match up with Pascal's triangle because we're just going to carry down the 3. So you got to keep that in mind, is that you're not just copying down the numbers of Pascal's triangle, you're applying his method, right? And that method is add the previous two kind of neighbors together if you can. Otherwise, you just copy down if there's only one option. So 3 plus 6 is 9, 10. And so far, mental math is getting the job done. Full disclosure, I actually just had to waste about 8 minutes of footage because I made a mistake. So I just chose to restart. So I'll be careful this time. But my advice to you guys would be just have a care. If you're unsure, get out the calculator. Just like me there, that's not 52, that's 62, 55, 28, 8, 90. And I should say too, if you want to pause the video and just try this one on your own, fantastic. You can unpause or fast forward to check when you're ready. Feel free to do that. That'd be a great idea. Otherwise, you can just kind of follow along, but I'm just applying Pascal's method. It's a fairly straightforward method to apply. It's just that the numbers get kind of big, and you got to be careful just to keep track of kind of where you're at. 207, 200, 119, 45, and 10. 2 more rows to go. 297, 407. These aren't too bad to add. 319. Careful here, 164, 55, and 11. And we have 1 more row to go. And then we've got the number of ways to get every slot. 12 ways to get this slot, 66 ways. Just taking a bit of a breather from the heavy lifting. Copy down the 297 here. That is 704, I believe. But you know what? At this point, I don't want to reshoot this. So I'm just going to double check. Of course, it's 704, but 319, 726, 319 plus 164, 483, and 164 plus 55. Now, we've completely determined the number of ways to get to every single slot. We are focusing in on what our chances of getting $10,000 are. We know that there's 219 ways to get $10,000 on this Plinko board dropping from slot A. But how many total ways were there for a Plinko chip to reach the bottom? So to get that, we add up all the different numbers we have on the bottom. We have the number of ways to get to any individual slot. 219 plus 66 plus 13. All right, we got it. Now I've done this assignment like at least 20 times with a variety of classes. Any class that does kind of probability, I like to do this one with. So I know what number to get. And when I shot the video previously, I did not get that number and I knew something was up. All right, so 219 ways to get $10,000 of 2,508 ways to reach the bottom. Now I'm going to give you guys a strong hint moving forward. So moving on to page 3, I asked you guys to determine the now that we've done the total number of ways to get the bottom and 10,000, you calculate the probability of getting the $10,000. So I'm going to do that with you for slot A. So there's 219 out of 2,508 ways to reach the bottom. Well, what is that as a percentage? That's our percentage chance of getting $10,000. Shooting this video during my school's opening announcements and stuff may not have been ideal, but we're just going to roll with it. 8.73%. From that slot, you have an 8.73% chance of getting $10,000. The idea with this assignment is, can you do better? So we've done slot A. You guys are now going to do slot B, right? So you start a Plinko chip in slot B and you apply Pascal's method. I'll stop there, but go down the bottom, same idea. Maybe you want to shade in a little border for the regions you cannot get to, right? I would probably strongly consider that. Just give you a little visual boundary just to make sure you don't go beyond that. And yeah, the goal is for you guys to see, do my chances improve by dropping from slot B? Do my chances improve by dropping from slot C? Again, I might just start it off and 1, 2, 1. And then these are regions you can't get to right here. And I think I'll leave it with you guys from there. And then finally, slot D. Ultimately, the goal again is which one gives the best chance. So once you guys do all those, you're going to do a few discussion questions, finding the probability of getting to each slot. I've shown you how to do that. Afterwards, you should be able to make a choice on which slot you would pick to maximize your chance of winning 10,000. Briefly explain why you chose that slot. And then I've asked you, why are we only doing 4 slots on the Plinko board? Look, there's 1, 2, 3 more slots we didn't analyze. Why are we not analyzing those slots? So with a bit of reflection, you can probably figure out why we didn't have to analyze those guys. And then I have you guys do a little numerical investigation, if you will. We're going to focus in on slot D. So when you're finished doing your analysis for slot D, you're going to put the number of ways to win this amount into this table here. Now, for example, I'm not saying this is going to happen. You will get some different number, okay? Just to be clear. But let's say, I don't know, you got 342 ways to get to that 0 and 342 ways to get to that 0. Hypothetically, okay? Well then, 342 plus 342, that's 684. There would be, I'll even show that work here, plus 382. It would be 684 ways to get that 0. So when you're doing this, make sure if there's a dollar value that has 2 slots, make sure you're adding those up, okay? There's only one 10,000 slot, so you just have one number here. Make sure the total you get here matches the total that you get here. That's going to be a little self-check for you guys, okay? So let's make sure those totals match up. Then what are you going to do with that information? I'm going to erase that since it's not, I don't want you guys putting that into your own assignment because it's not the right number. You're then going to get the percent chance of winning that amount. by doing the same calculation you did in discussion question 1. You have the total number of ways to reach the bottom of this point. You have the number of ways to win that dollar amount. So you're just simply dividing the number of ways to win by the total, and you're getting a percentage. Make sure they add to 100%. They might add to 99.9%. If you're doing a bit of rounding, that's okay. What we're going to ask is how much money do we have to give away if somebody keeps dropping in slot D? So to do that, we're going to look at how many times each slot would be hit in 1,000 Plinko drops. For example, let's say that my percent chance of getting 0 is 29.2%. Well, in 1,000 times, 29.2% of 1,000 is 292. And that's it. This column should add to 1,000. When you take your percentages, convert them to a number out of 1,000, they should all add to 1,000. And to find the money made in these 1,000 attempts, well, if 292 times you're giving away $0, well, if you multiply, that's 0. Let's say, just for argument's sake, let's say you got 168. We might actually just have to go through O Canada here. You would multiply that by 100, and you would get $16,800 given out from there. So that's the idea. Afterwards, you're going to add up to get the number of how much prize money is awarded in 1,000 times. And in a Plinko game, you can only get 5 attempts. So I've just coached you. You're going to divide that answer by 200, and this answer by 200. That's going to give you how much money it would be given out on average for 5 Plinko drops. Good luck with your assignment, guys.